So, hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. So, in today's session, we are going to discuss about the transient analysis of series RLC circuit with differential equation. Okay. So, here, we need to discuss about the transient analysis of series RLC circuit with differential equation. Okay. So, here, in this case, I am taking the three elements here, one resistor, one inductor, one capacitor. So, these three are connected in series across one voltage source. So, here is the circuit: resistor, inductor and capacitor. So, these three are connected in series across one voltage source. So, resistor, inductor and capacitor. So, voltage is V plus minus. So, here initially if t equal to 0, then current is 0 and this is switch. So, here if it is a closed circuit, the electrical current is directly passes through the resistor, inductor and capacitor, because in series circuit current is constant, but we are having the different voltage drops at resistor, at inductor, at capacitor. So, here voltage drop across the resistor is VR, voltage drop across the inductor is VL, voltage drop across the capacitor is VC, right. So, now write the voltage equation of the given element. At resistor R, voltage drop VR equal to I into R. At inductor L, VL equal to L into di divided by dt. At capacitor, Vc equal to C into 1 by C into integral of I dt. Let us take as equation number 1, 2 and 3. So, we are having the voltage equations: VR equal to I into R at resistor, at inductor L, VL is equal to L into di by dt, at capacitor Vc equal to 1 by C integral of I into dt. Now, it is a single loop. So, in this single loop apply KVL here. So, here I am applying the KVL, that implies we will get plus V minus VR minus VL minus VC equal to 0. Then V equal to VR plus VL plus VC. Now, substitute these three equations here in this equation. Then we will get V equal to VR I into R plus VL L into di by dt plus Vc 1 by C integral of I dt. Right. Now, we have to simplify this equation. For that, we have to differentiate on both sides. So, we will get dV divided by dt equal to R into di by dt plus L into d square I divided by dt plus d by dt of 1 by C integral I dt. So, integral d by dt get cancelled, then the remaining term is 1 by C into I. Now, dV by dt 0 equal to, so this equation I am writing like this: L into d square I divided by dt square plus R into di divided by dt plus 1 by C into I. Now, in this equation, take L as a common here. So, L into d square I divided by dt square plus R by L into di by dt plus 1 by LC into I equal to 0. Now, L goes this side. So, 1 by L into 0 means 0. Now the equation is d square I divided by dt square plus r by L into di divided by dt plus 1 by LC into I equal to 0. Okay. Now this differential equation I am writing in terms of d. So di by dt is equal to, I am taking as a d. So here d square plus r by L into d plus 1 by LC equal to 0. So this equation in terms of a square plus 2ab plus b square equal to 0. So for that, so we are having the equation d1 and d2 equal to, the equation is minus b plus or minus under root of b square minus 4ac divided by 2a. So that equal to, what is b here? So a equal to 1 and b equal to r by L and c equal to 1 by LC. Now substitute this ABC value in d1 d2 equation. So here d1 comma d2 equal to, first b value. So b is r by L. So minus r by L plus or minus under root of r by L whole square minus 4ac. So 4 into 1 by LC divided by 2 into a. So 2 into 1. Now that is equal to minus r by 2L plus or minus under root of r divided by 2L whole square minus 4 into 1 by LC into 1 divided by 4. So 4 get cancelled. So we'll get roots minus r by 2L plus or minus under root of r by 2L whole square minus 1 by LC. These are the roots d1 and d2. So first root d1 is equal to minus r by 2L plus under root of r divided by 2L whole square minus 1 by LC, first root, and second root is d2 equal to minus r by 2L minus under root of r by 2L minus r by 2L whole square minus 1 divided by LC. Now by solving the entire equation, we will get the current response by solving entire equation. So we will get the equation like this. Let us take this minus r by L I am taking as a K1, this equation I am taking as a K2. Now the equation will get like this. So I into d minus K1 plus K2 into d minus K1 minus K2 equal to 0. By solving the equation, we will get answer like this. Now again by solving this equation, we will get I equal to C1 e to the power of K1 plus K2 into T plus C2 into e to the power of K1 minus K2 into T. This is the current response of series RLC circuit. Okay. So in this series RLC circuit, so we have to find out the roots here. After that, we have to calculate the current response, that is I equal to C1 e to the power of K1 plus K2 into T plus C2 into e to the power of K1 minus K2 into T. Okay. So this is about the transient analysis of series RLC circuit with differential equation. Okay. So thank you one and all.